is our board?
This is 11.3. Wait,
I'm not done talking. 11.3.
we're going to do 9 through 11 right now. We're on page 775.
775.
9 through 11. We're going to try to get through 43 or 53. 43. Okay? Alright. So, first of all, we need to prove.
Damn, Dan, you're trying to.
Ready? So we got to prove that this is the same as this using these. So these are your trig identities. Alright, we already know that cosecant is the same as the inverse of sine, and secant is the inverse of cosine, and cotangent is the inverse of tangent, right? But there's a new one. Cosine squared plus sine squared is 1. 1 plus tangent squared is secant squared. Cotangent squared plus 1 is cosecant squared. Along with the tangent is sine over cosine. Cotangent would just be that flipped, cosine over sine. And then you have these are kind of cool too, where you have the sine of the negative angle, theta, right, is equal to negative sine. But the cosine of negative theta is equal to just cosine. So they're the same. So the cosine of a negative, guys, the cosine of a negative is equal to the cosine of the regular. And then you got tangent of a negative is equal to the negative tangent. Okay? So what we want to do is try to prove this is this, and it's actually really quite simple, as long as you can see the pattern. Does anyone see a pattern going on with sine minus cosine and sine on the bottom? How they can manipulate this by using any of these. So you see any patterns going on? Now remember, what you want to get to is 1 minus cotangent, right? So at some point you want to have a cotangent in there. So you're looking for this guy or this guy. Yeah, that's about it, right? So does this have anything to do with this guy? Do you see a tangent in it? No. But do you see a sine and cosine? Yeah. So it's most likely leading you to this. Okay? So if I actually split this up and say that this is sine theta over sine theta minus cosine theta over sine theta, right? Right? If I do that, what happens? Well, this becomes 1, right? Sine over sine. That's just 1. Minus, and then what's cosine over sine? Cotangent. Bang. Done.
Bang. Damn, that was easy.
It's easy. Okay? It's easy when you see it. It's all puzzles from now on. This is the start of your puzzles. This is the start of calculus. This is what you're going to use when you get to calculus. You've got to use these trig identities to turn your puzzles into pieces that you can use. Okay? This is probably why I love math the most. When I got to this in college, this was like fun. Yep, I was loving it. I love puzzles. I love trying to make new pieces and making it work for me. Right? Alright, so here we've got secant. We got 1 minus cosine. This took me a little bit. You saw me back there going, what the heck is going on with this?
When don't you do that?
But when I'm looking at this, I see tangent squared. Now, I know I need to use the tangent squared, right? So that brings me up to this guy right here. Right? So somehow, I've got to get this tangent squared to equal, now if I move this over, it's going to be secant minus 1, right? Okay? So somehow I'm going to have to get secant squared minus 1. And I'm like, oh wait, well I have the secant squared, right? Now I just have to get it to be secant squared minus 1. So then what can I do with this 1 minus cosine squared? And I noticed up here that I have a cosine squared, right? And I have a sine squared, right? And so if I take that cosine squared plus sine squared, right, and I move it. Are you guys paying attention, Wyatt?
Yeah.
Really?
Yeah.
If I move this, right, because I got to be able to plug this in so I have 1 minus cosine squared. Well, that would be sine squared would equal 1 minus cosine squared. Right? If I just subtract cosine from both sides. So now I can plug this in for that. So I've got secant squared, right, times sine squared is equal to tangent squared, right? Then I want to think of, well, when is tangent equal to anything? And I'm like, well, tangent's equal to sine over cosine, right? So is there a way I can turn this secant into a cosine? Right? And doesn't secant equal 1 over cosine? Right? Right here? Right there? Doesn't secant equal 1 over cosine? What about stop? Okay? So, wouldn't secant squared equal 1 over cosine squared? It just means that they multiply against each other, right? So in this case, then I would have sine squared over cosine squared equals tangent squared, right? And so at this point, I can look up here and go, well, yeah, tangent equals sine over cosine, right? So it just makes sense that tangent squared is equal to the sine squared over cosine squared. And so now I proved that these are equal, that both sides are equal. Pal!